Okay, all right, guys. So um, we went over a bunch of like trig rules when we earlier in the year. Okay, so this is probably like a bunch of material that you haven't seen in a very long time, but it is something that should be tested as well. So one thing I do want you to remember is that when I see the word arc, sine, cosine, or tangent, it's the same as saying sine to the negative 1 power. And so they might write it either like this or like this. Means the same thing. So I want to show you a couple of tricks here. I guess you can figure out your graphs if you remember these rules here. So this is the arcsine graph. So the arcsine graph looks something like this. The original one. It goes through the origin. This over here should be pi over 2. This would be pi over 2. Negative pi over 2, I should say. And this is between -1 and +1. Okay, so if you remember how to do with the horizontal and vertical shifts, you should be able to get to the answer without having to do the other stuff. So that's what I'm going to focus on here. So horizontal shift and the vertical shift. So here, remember that this is going to be A, B, C, and D. And so the vertical shift is just what is D. So here, this is the D value, this is positive, so I went up by pi over 2. So that means at this point in the vertical direction, went up by pi over 2, so somewhere right here. And now let me deal with the horizontal shift. So horizontal shift comes from the C value. Okay, but you don't just put a 1. Remember, if this is in the parentheses, I need to take it out, the B value. Okay, so if I were to take this B value out, okay, plus I'm also taking a 2 out of here, so that would mean my C value is actually 1 divided by 2. So my C is 1/2, and because this is a plus, that means I move to the in the negative direction, to the right. So 1/2 to the right. So this point went up and to the right by 1/2. So right here. So my graph would now look like this. Okay. So the original graph for the cosine looks like this. Oops. And again, I'm going to deal with horizontal shift, vertical shift. So starting with vertical, this is D. So that means I went up by 2 units. So right here, guys, I'm sorry, this is at 1. So I went up 2 units, and then to the horizontal, remember, take the B out. I went 1 divided by 3, and since this is negative, I went to the, excuse me, I'm sorry, I went to the left over here, and I put right. So I moved to the right, so I'm moving this way. So my new graph's gonna look like that. Okay, so if you remember those tricks, you shouldn't have to deal with the rest of the problem. Okay, so evaluating trig function, you can see down here I have the unit circle. You all have your big unit circles also that I gave you. At least you should have them. Okay, so these are just to remember, a reminder on these things here, guys. Sine is over h, a over h, O over a, and then these opposite ones are just, you just turn these over. Okay, so on any one of these, the x and the y, this is the sine and the cosine. So sine and cosines are easy, guys. You just either, excuse me, the other way around. Alphabetical order, guys. C comes before S. So the x value is always the cosine, the y value is always the sine. The x is always the a value, the y is always the o. Okay, and if I'm dealing with the unit circle, h is always equal to 1. Okay, so to start off with this one, we'll only do like the first two here. Sine of 60 degrees. So I'm going to go to 60 degrees. Right here. These are the coordinates I'm dealing with. So it says sine, so that's good because that means it should be an easier problem. So the first number is the x, the second one's the y, this is the cosine, this is the sine. So my sine is just equal to square root of 3 over 2. Okay, so the next one, 5 pi over 4. So I'm going to go to 5 pi over 4. It's right here. These are my coordinates. So at 5 pi over 4, my coordinate is negative square root of 2 over 2 and negative square root of 2 over 2. So remember, x and y, a and o. So tangent, that's not sine or cosine, so I'm going to have to do some more work here. Tangent is equal to O over a. So I'm going to divide the two numbers here. So O is negative square root of 2 over 2 divided by a, which is also negative square root of 2 over 2. So if I divide these two numbers, guys, and since they're both negative, everything's going to cancel out. It's going to equal 1. Okay, so I'm going to go ahead and skip on to the next one. So right here, these are a little bit different. Okay, so here I see that I have the arc tangent on the outside, and so what I'm really looking for is I'm looking for the angle for whatever this inside part equals. Like where, at what angle will I get it to equal this? So I need to solve the inside first. So here it says cosine at pi. So again, I'm going to look at my unit circle. This is pi. X and y, so this is easier. Cosine sine. My cosine equals negative 1. So cosine of pi equals negative 1. So what I'm looking for is, where does my angle, my tangent angle, equal negative 1? Okay, so if I divide the two numbers, remember tangent is O over a. If I divide the O and the a, let me put the big one, the O and the a, where would it equal 1? Negative 1. So if I divide these two numbers, square root of 2 and square root of 2, it equals positive 1. That's not what I'm looking for. If I divide these two, square root of 2 over 2 divided by negative square root of 2, 2 over 2, that equals 1. So here my angle is 135 degrees. That's not the only place though. If I divide these two numbers, it equals positive 1. And if I divide these two, it also equals negative 1, which is what I'm looking for. So my other angle would be 315 degrees. Okay, so that's what I'm looking for. Okay. Now here, we're looking for cosecant, but see how this doesn't have the negative 1 on the outside? So I'm going to deal with this inside part first. So when the -1 is on the inside part, we're going to make a triangle. And remember, sine is equal to O over H. It's also equal to 4 over 5. That means my O is 4. So we'll make an angle. O is 4. H is 5. And I need to find A. So go ahead and solve for it anyway. A is going to be, remember this is a triangle, so it's just going to be A squared plus B squared equals C squared. So 4 squared plus B squared equals 5 squared. So this last missing, sorry, I guess I should have put an A. It equals 3. Okay. So I solved the entire triangle. Again, what I'm looking for is cosecant. So cosecant is equal to H over O. And I know from my diagram, the one I already solved for, H is 5 and my O is 4. So here I didn't even have to solve for that missing side, but this is my answer right here. Okay, so just make sure, guys, this is the difference. The -1's on the inside here, -1 was on the outside. So 2 different methods, even though the problems look the same. Okay, and the last one's here. Excuse me. So, this one's going to require you to use some of your identities, the ones that you see here. First page. Okay, so these are kind of important here. Don't forget, they didn't write this one for you, but the original one looks like that. Okay, so on a problem like this, what I would do is, I'd put all the tangent squares together. So here's this one squared, this one squared. So first thing is I'm going to subtract tangent squared. And since I have 4 over here and I'm taking away 1, I'm left with 3 tan squared theta minus 1 equals 0. I'm going to move this, so plus 1, 3 tangent squared equals 1. And I want this by itself, so divide by 3, divide by 3. So tangent squared theta equals 1 over 3. Okay, so here the square root, so tangent theta should equal plus or minus square root of 1 over 3. You should be able to just take it up to here and you'll be fine. Okay, so last one here, proving an identity. So this is the one where you're actually going to be using these other things. You got to manipulate it. So you have to start with a more difficult side, which right here, guys, this is the one that has more stuff going on. So this is the one I'm going to use. Okay, so this is some other stuff you need to remember, and this is what kind of sucks about these problems. they don't give you the original identities as well. So